This expectation or mean value, which is represented using the notation mu or capital E of x, where capital X is the random variable and f of x is the probability density function. A random variable x can be continuous random variable or discrete random variable. For example, when you consider roll number of a student in a class or number of students in a class, these are examples for discrete random variable because these variables cannot be equal to 3.5, 9.7, etc. They will be exact natural numbers. And when you consider variables like height of a student, weight of a student, it may be represented using decimals. That means weight of a student may be 73.5 kg, height of a student may be 167.5. So we make use of real values. The range of discrete random variable will be finite set and range of continuous random variable will be an interval, because in case of continuous random variable we can express the values of the variable in a continuum of interval, or it can be a continuum of any part of real line. But in case of discrete random variable we have to strictly stick on to natural numbers to represent the values of the variables. Regarding probability density function, for each observation xi in the considered distribution, we have f of xi which gives us the probability of the observation xi. For a discrete distribution, for each observation xi, there will be distinct f of xi value. When you consider a continuous distribution, the probability density function will be a continuous function f, to which when we give each xi values, we will get the desired probability of that particular xi. When we input xi to the function f of x, we get the desired output for f of xi, which is the probability density for that particular observation. In discrete case, you may be given a table that shows probability of each observation xi. But in case of continuous variable, it's enough to give the well-defined format of the continuous function f of x, which will help you to find out the probability of the observations xi. When you consider f of x as the probability density function or PDF of the random variable x, we have expectation of x given by summation xi f of xi. Here xi f of xi is considered because for each xi there will be distinct probability f of xi. When we add up all these, we get the desired expectation. If we are given n observations, we have summation I ranges from 1 to n for a discrete case, and for a continuous distribution, expectation of x equals integral x f of x dx. The summation gets replaced by integral sign when we consider a continuous distribution. Variance of probability density function f of x notated using sigma square. Sigma square is actually the square of standard deviation. If the distribution is discrete, we have variance equals summation over I x minus mu the whole square f of xi, where mu is the expectation. And if you are considering a continuous distribution, we have variance equals integral x minus mu the whole square f of x dx. This is the case when you have to replace summation by integral sign if you are working on a continuous distribution.